Hi everyone, welcome to Mr. Wagon's math class. Today we will be talking about something new that's called relations and functions. To understand the lesson, let's talk about something we already know, vending machine. We use vending machine by inserting money or a credit card. We input some kind of payment and then we choose what drink we wanted to choose at this point, and an output is what comes out of the vending machine. So you got an input and you have an output. In today's lesson, we will discuss relations and functions. Let's start with relations first, using the input and output just like the vending machine. A relation pairs inputs with outputs, and the relation can be represented by an ordered pair, X and Y, where X is the input and Y is the output. Or it can be represented by something called mapping diagram. So what is a mapping diagram? To understand that, let's think about a treasure map, because mapping works just like a map. The map shows direction to get from one place to another using arrows. And that's how the mapping diagram works. This is how a mapping diagram looks like. Watch how the mapping diagram shows the relation between the input X and the output Y. The arrows shows which input is related with which output. Then you can write the ordered pair from the mapping diagram with X and Y, where X is the input and Y is the output. Watch how the input 0 has an output of 1 because the arrow from the input 0 is pointing toward the output 1. So I can write it as an ordered pair 0, 1, where 0 is the X, which is the input, and Y is the 1, which is the output. Now the input 1 is paired with the output 2 as an ordered pair would be 1, 2. The input 2 is paired with the output 4, so as an ordered pair it'll be 2, 4. Let's practice writing the ordered pair from this mapping diagram. Remember, X is the input and Y is the output, and the arrow shows which input paired with which output. The first one is 0, and the arrow pointing at the output 0. So as an ordered pair, 0, 0, where X is the input and Y is the output. Now the second one, 2, and the arrow is going to the output 1. So the ordered pair would be 2 and 1. Now watch how the 2 also paired with another output, which is negative 2. To write that down, 2 is the X and negative 2 is the Y. Now 4, the arrow is pointing at negative 3. As an ordered pair, X is the input 4, Y is the output negative 3, and I know this input related with this output using the arrows. Remember we said a mapping diagram shows the relationship between the input and the output. In this case, the input represents the names and the output represents the month that person is born. And the arrows shows which month each person is born. So the relationship between the person and the month born is shown in this mapping diagram. Watch how Mona, the arrow is pointing at the output August. That means Mona is born in August. Laith pointing at January using the arrow, pairing the input with the output. So Laith is born in January. Nancy with the arrow pointing at April. That means the input Nancy is born in April. Jacob is born in November because the input Jacob using the arrow paired with the output November. Now let me ask you this question. Can the input Mona has more than one output? Which means can she be born in more than 1 month? Absolutely not. Which takes us to the next concept of today's lesson called a function. The relation is a function only if every input is paired with exactly one output. Otherwise, that relation is not a function. Now let's talk about this example of mapping diagram that shows the relation between the input X and the output Y. Does that relation represent a function? Let's find out. If every input paired exactly with one output, then it is a function. Watch how the input 1 is paired only with the output 15. The input 2 has exactly one output, which is 30. The input 3 has exactly one output, which is 45. And the input 4 has exactly one output, which is 60. Since the relation is a function, can we describe that relationship? Is there a pattern between the input and the output? Let's find out. Watch how the input goes from 1 to 2, from 2 to 3, from 3 to 4. So the input increases by 1. Now let's talk about the output. The output is from 15 to 30 to 45 to 60. That means the output increases by 15. So yes, the relation is a function, there is a pattern. As each input increases by 1, the output will increase by 15. Now let's practice determine whether the relation is a function using those two examples. Let's start with the first one. You always ask yourself, does every input has exactly one output? Does every input paired exactly with one output? -5 is paired with 3, -3 is paired with 1, 2 is paired with 1, and 6 is paired with 3. None of the input is repeated, and every input has exactly one output, and I can prove it using the ordered pairs. So yes, the relation is a function because every input has exactly one output. Now let's talk about the second example. You have -½ paired with 2, -½ paired with 4. Does every input has exactly one output? Absolutely not. So no, the relation is not a function because the input -½ has two outputs, which are 2 and 4. Here's a real-world application. As store sells previously viewed movies, the table shows the cost of buying 1, 2, 3, or 4 movies. Here's the table that has the number of movies and the cost for those movies. Let's answer those 3 questions. The first one, use the table to draw a mapping diagram. For me to draw a mapping diagram, first, I need the input and I need the output box. The movies are the X, which is the input. So I will transfer all these numbers into the input box, 1, 2, 3, 4. And now I will transfer the money or the cost in the output, which is the Y. We'll start with $10, $18, $24, and $28. Now to show which input is related with which output, we draw the arrows. So the cost for 1 movie is $10, 2 movies $18, 3 movies $24, and 4 movies $28. And that's how the mapping diagram works for transferring this information from a table to a mapping diagram. So know that a relation is represented by a table or a mapping diagram. Now, is the relation a function? Ask yourself again, does every input has exactly one output? Does every input paired with exactly one output? Yes, the relation is a function because every input has exactly one output. Since the relation is a function, how does the cost per movie changes as you buy more movies? So there is a relation between the input and the output. Let's find that out. 1 movie costs you $10. 2 movies should cost you $20. But that's not the case. 2 movies are costing you $18, which is $2 less. Or if you divide $18 divided by 2 movies, that means it costs you $9 per movie. $24 divided by 3 movies gives you $8 per movie. And if I divide 28 divided by 4 equals $7 per movie. So 1 movie costs you $10, but 2 movies cost you $18, which drops the cost $1 every time you buy an extra movie, which means every additional movie bought, the cost per movie decreases by $1. In conclusion, the relation is a function only if every input has exactly one output. A relation can be represented as an ordered pair, X and Y. We can write the ordered pairs from mapping diagram that shows how the input X is related to the output Y using arrows. We also know that tables and graphs shows a relation, and we can write an ordered pair from a table and from a graph. That's it for today's lesson. You guys have a great day.